Greetings to everyone. Myself Vikesh Maurya. I'm going to present my manufacturing technology course project. We are a team of three members. I with Vinay and Saurabh had done the project. Sir himself had given this project. Our project is to develop a Python or MATLAB program for merchant circle diagram. We have chosen to do it in Python because in Python we can run different cases of code differently. Now, in introduction part, the abstract why what is merchant circle? The merchant circle diagram is a graphical representation of the forces acting on the workpiece, and it is done when we have orthogonal cutting. Like there are two types of cutting. One is orthogonal and second one is oblique cutting. In orthogonal cutting, the tool is perpendicular to the cutting and cutting edge clears the width of the workpiece on either end. Only two components of cutting forces are in action on the cutting tool. While in oblique cutting, the cutting edge is inclined at some angle to the current velocity factor. The cutting edge may not clear the width of the workpiece in that case. So, condition required for successful metal cutting operation, the relative motion between the cutting tool and workpiece. The workpiece cutting tool must be held rigidly. The, the cutting edge should be sharp, and we should have optimum speed, feed, depth, etc. And the aspect of cutting forces concerned in metal cutting, we should have magnitude of cutting forces and their components, the direction, the angles, the locations, and the patterns of the forces, whether it is static or dynamic. Why we need that cutting forces? Cutting forces must be known because to determine machine tolerance and designing the stiffness, whether a workpiece can stand that cutting force. One have to know well before the magnitude of cutting force that it is going to face during the cutting operation. And the study of behavior of machinability also becomes important. And the estimation of cutting forces. We can find out the power consumption from that using velocity and cutting force. And what is the benefits of knowing that cutting forces beforehand for estimating of cutting power consumption and for designing of our machine tool fixtures and tooling system to determine effects of various machining parameters on produced cutting forces and to monitor the conditions of the tools and the cutting machines. Here, this is a merchant circle diagram in which you can see this is our tool having a rack angle of alpha. This is our cutting velocity here. This is our cutting force. This is thrust force. And at a shear angle, we have shear plane. F. This is shear force. This is shear normal force. And here we have friction force at an angle alpha downward. Here it is normal force. Here in this notation, lambda is our friction angle. This is resultant one. We can see a perfect circle in which all the forces are well drawn at particular angles. Yes. We will try to make a code that can give us this merchant circle at certain parameters of known forces, velocity and angle. To make a merchant circle diagram, we need to consider certain assumptions like tools should be sharp, the workpiece should not deform, uniform distribution of forces, workpiece is rigidly fixed and perfectly plastic, shear angle adjusts itself minimum work, and the width of the chip should remain constant. Continuous chips should produce no built-up form. No consideration is made of the inertia forces of the chip. And the advantage of merchant circle mentioned here, it is easy, quick, and reasonably accurate determination determines the several forces. Equations relating to different forces are easily developed. Frictions between the tool chip interface and the dynamic yield of shear strength can be easily determined. And certain disadvantage of merchant circle is it can applied over only orthogonal cutting, not on oblique cutting. And by ratio of friction and normal, the merchant circle diagram gives the aspect of coefficient of friction. It is not actual, but it gives apparent coefficient of friction. It is based on shear plane theory. Here we have Python code in Google Colab. Let's open where we have code by the link directly. There in Google Collaboratory, we will see this. I have copied and pasted the code here. We will see this code in real time. Okay. Here is my Google Collaboratory. The link directory open and access to everyone. Run anyway. Here we have our tree detail, and we have made three cases for different given parameter inputs. Like in case 1, we are taking input of cutting force on cut chip thickness, rack angle, friction coefficient, and cutting velocity. Let's quickly look into the code. We have import pandas, matplotlib, math, numpy, and we are taking inputs here, and we have used formulas to find our various forces. And finally, from here we are plotting points in the matplotlib and then joining them to find the forces, and then make using numpy and linspace we have drawn the merchant circle, and in which all the forces are involved. Let's run this and see whether what happens. No, it is taking input. Let's give 1200 Newton as our cutting force and uncut chip thickness at zero point 0.5 millimeter, zero point 0.7 millimeter as cut chip thickness, and say 15 degrees our rack angle. Let's say 20 meter per minute is our cutting velocity, and let's say coefficient of friction as 0.4548. Now, with these input parameters, we can get a nice merchant circle. Here you can see, and here we have taken these inputs. It gives friction angle, shear angle, thrust force, resultant force, friction force, normal force, shear force, normal to shear plane, chief velocity, shearing velocity, cutting power, and shearing power, power loss due to friction, and shear strain in cutting. All these values we can easily get with proper merchant cycle. Similarly, in case 2, we are not taking coefficient of friction or thickness like cut and undercut. We are directly taking the shear plane angle. We have given this input based on what parameters we can determine from our machine. Like it is easily, we can easily get to know cutting forces, rack angle, shear plane angle, and our coefficient of friction, cutting velocity. If we can find thrust force, then case 2 is perfect for that. In case 3, we have taken cutting force, thrust force, and thicknesses alpha and this cutting velocity. Here we have not taken and shear angle as our input parameter, shear plane angle. It also gives a different merchant cycle. Like all cases, it is nice. It gives the code is nice, and that's all in coding. Let's move to our slides. In conclude, we can conclude that we have seen the important aspect of cutting forces and why they are so important. And based on our coding, we can easily determine the various forces, and we can find the merchant circle diagram. And the advantage is that human errors in calculation is reduced. No chance in this case. And we can quickly and frequently calculate all parameters without any error just in seconds by applying this code. After getting all values, we are displaying it as an output on merchant circle diagram using matplotlib library. Moreover, this project helps us to learn much more about that library as well. There are ups and downs whether we need to learn various things for our diagram. We have did it and we have finally successfully completed it. Some of the sources that we have used here are manufacturing process and here slides. Let's open it. This one we have used these formulas we can get also this one. That's all. Thank you.